Let's try to create a custom deep flat implementation. So we are already having a flat with infinity, which can go up to any depth and flatten your array. So what's the requirement for the custom deep flat? For creating a custom function for that. So if you want to customize the behavior of the deep flatting, let's say before each and every deep flat, you want to append some string, or at the end of that, you want to do some operation. So there it's useful. So let's try to create a code for it in a recursive way where we will not be using any flat which is already available. We are just going to perform for looping statement, and whenever any uh, deep flat is coming up, or maybe a depth of flat array is coming up, we are going to again apply a recursion on top of it. So I'm having a sample array here, which is on the depth 0. It includes 1, 2, and 3. So it includes only 3 elements. Again, I will revise. This is the first element of my array. This is the second element, and this is the third element. Please do not get complicate yourself by looking into this code. You can simply consider it as a third element. So this array is holding the 3 elements, I can say. Only the thing is that my third element here is an array. In the level 2 of the depth, in this case, I can see there is, on the level 1 of the depth, again I can see my array is holding 1, 2, and 3 elements in it. So this is how on the level 1 of the depth, I'm having 3 elements. Again you can consider as a simple element, but in this case, it's an array. And in the level 2 of the depth, my array is included with 2 elements, number 5 and the number 6. So here we are with the depth 0, then depth 1 and the depth 2 here. So I'm going to create one recursive function here for this custom implementation. So you can see here in this particular example, we are having a function call which is having certain input and output out of it. So just focus on the input here, as the input suggests that there is an array on which we need to apply a flat operation. So the array includes 3 elements. The one that I just now discussed with you. This is my first element, this is my second element, and this is my third element. When I'm going to the third element, I identified there is again one more array there. So we need to recursively apply the same operation. So what I will do, and again for this particular array, I'll recursively call the same function by giving the input of this array. In the second call, you can observe the input includes my nested array, which is being highlighted here with the red color. Again, I'll start working over here. This is 3, this is 4. Again, I identified there is an array. So for this array, which includes 5 and 6, again, I'll apply a recursion over here. Now, for this 5 and the 6, both are completely like just an array. There is no nested array anymore. So we are up to the final depth, we can say, of the recursion. So the output of my function will be 5, 6. This will be returned back to the previous call, and I can see here 5, 6 is coming up, which is being concatenated with the previous 3, 4. Now the output of this particular function is 3, 4, 5, 6, which is being given back to the previous call 3, 4, 5, 6 here, and it is being concatenated with the original 1, 2. And finally, I'm getting 1, 2, 3, 4, 5, 6, a flattened array. Previously, the input was with a depth 2 or 3 that we have given. So this is how, even if my array is having any number of depth, I can solve this by recursion. For each and every depth, the recursion function will call itself again, and the depth will be solved. Let's try to implement a recursive function for this. So here I'll create a function. The name of the function I'll give deep flat. What will be the input for my deep flat? As per this particular diagram here, the input will be the array. Okay, what I will do here, very first thing, I'll create a temporary array here, for which I'll give a temp array name, which is initially empty. What will be the job of this temporary array? Whatever this 1, 2, it will just keep looping over here and it will keep saving inside a temporary array. And as soon as it is finding any array, it will recursively call the same function. So what I'll do here on this particular array, I'll apply for each statement and for each and every element. So what is this for each now? In this case, this element is 1, 2, and the third time my complete array. For the sake of understanding, what I'll do, I'll just console this element. So I should be able to get this particular console log 3 times. Let's call the deep flag here by giving the array input. I'm going very step by step. That's the reason I'm consoling it and I want to verify on the console. So you can very clearly see this line number 8 is getting executed 3 times for the first element, then second element, and finally it is getting executed for the third element. That's the reason we are able to see these 3 logs. Again, not to worry about the third element because that's again an array, but in this case, it's just an element for us. So what we will do, as we are traversing using our for each statement here, so this 1, 2, we will be keep storing inside our temporary array. So here, what I'll do, I'll say if the array dot is array element. So here I want to perform the recursion. Else, inside my temporary array, I want to keep pushing the element. What exactly happening here? So we are having firstly 1, then 2. So the one element, it's a just number, it's not an array. So it will go to the else statement, pushing our element inside this temporary array. So this temporary array will hold number 1 now. When next time it will come up with number 2 here. So what it will do, again it will go to the else part and it will push number 2 inside the temporary array like this. And when it is coming third time, it's an array. And there's the recursion start. So in this time, is array will return true because your element is an array now. And here you need to recursively perform some operation, the same function you need to call. And the same you can see here, it is calling the recursive function again, and for which the input will be your third element of the array, which is this 3, 4, 5, 6. So what we will do, we will recursively call the deep flag again. As per this diagram, the second box, the second recursion is getting called, for which we have given the 3, 4, 5, 6 as an input. That's very much perfect. But whenever the function call will complete, we need to again give it back to the original call. So we need to complete our temporary array with that. So what I'll do here, I'll say the temporary array equals to temporary array dot concat. So what is this temporary array in our case? So this is 1, 2 is being held by our temporary array. I'll remove this from here now because you might have understood how that temporary array is working. So in this temporary array, we are holding 1, 2 now. So what is the result will come up out of this second recursion 3, 4, 5, 6 that I want to concat with 1, 2. That's the reason I'm saying temporary array dot concat, and I want to concat with what are the results are coming out of the deep flat. And again, the deep flat results will come into an array. So I need to use a spread operator here. So whenever this deep flat operation will complete at the end of this for each statement, I'll return the temporary array. In this case, when we are again calling the last one by giving the 5, 6 as an input, you can see the for each statement will execute 2 times. Once for the 5 and once for the 6 one. And there the for each statements complete, and inside the temporary array, we will be getting 5, 6. That will be returned. When we are returning that, it is coming back here. 5, 6 is getting concatenated with your temporary array. Your 5, 6 will get concatenated with your temporary array, which is holding 3, 4 here. Now this second recursion will complete its execution and it will return 3, 4, 5, 6. And this will be given back to the original call over here, and we are concatenating with the temporary array again. That is happening on line number 9. And after that, the final array is ready and we are returning our temporary array, which is holding the final outcome 1, 2, 3, 4, 5, 6. So this is how we have implemented the dflat functionality without using a flat which is available inside array. Let's try to see the outcome. Okay, that's perfect. So if I use instead of dflat, which is we have custom build now, I can also use array.flat with infinity. So this is exact similar in this case, and there will be no difference in the outcome. Both will give you the exact difference. But what if whenever any new depth recursion is happening or the new flat happening for any new depth, you want to append with a number 0 here, or maybe the number -1, so that for any specific purpose in your programming. So what I mean to say with that, if this is 1, 2, so your output should be 1, 2. After that, you're getting an array here that you're flattening. So what you should do, you should add -1 here. Then you should keep deflatting your array. So it will be 3, 4. Again, there is an array that you need to flat it. So again, what you should mention here, -1. And here, 5, 6 will come up. So this is how whenever a new flat is happening with a new depth of the array, we just want to apply -1. Is this possible with the existing implementation? And this could be your project requirement in certain cases. So you have to build the custom implementation by using a recursion like this. In our case, what we can do, whenever we are performing a concatenation with the results of the D flat, so what I can do here, I can simply say, I want to concatenate -1, and then I want to apply this D flat results. So what are the results are coming up from the previous function over here? So the concatenation, before applying the concatenation here from the results of the D flat, I'm giving one extra element that is -1. So in between the original 1, 2 and 3, 4, 5, 6, -1 will be added. Let's see how it works. You can see the results here. So we are having 1, 2, 3, 4, 5, 6. This is a normal inbuilt one, deep with the flat with infinity. And at the below one, we are have the custom implementation where you can see -1 and the -1. So before flatting any new depth, the -1 is being added. Again, if you want some more complicated behavior, for example, at the end of the each depth, you want some different number to be appended, maybe different symbol. Of course, you can do that in this customer implementation. So this is the benefit for the custom D flat creation.